morning, students. Welcome to the fifth session of probability class. In the previous class, we started off with problems on multiplication theorem on probability, and also we solved certain problems on independent events. We shall continue with problems. Write down the next problem. If A and B, if capital A and capital B are two independent events, if capital A and capital B are two independent events, then the probability of occurrence of at least one of A and B, then the probability of occurrence of at least one of A and B is given by 1 minus P of A dash into P of B dash. Then the probability of occurrence of at least one of A and B is given by 1 minus P of A dash into P of B dash. I repeat the question once again. If capital A and capital B are two independent events, then the probability of occurrence of at least one of A and B is given by 1 minus P of A dash into P of B dash. So you can see here in the given question, it is given that two events A and B, they are independent events. So by definition of independent events, what can we say if A and B are independent events? Well, I can write the solution like this. By data, I can write P of A intersection B is equal to P of A into P of B, right? Since A and B are given to be independent events, we have by definition of independent events that P of A intersection B equals P of A into P of B. Now, what is the question asking us to show? Okay, it is asking us to prove that probability of occurrence of at least one of A and B. So probability of occurrence of at least one of A and B. What might that be? That is nothing but probability of the event A or B, right? So it is saying that occurrence of at least one of A and B. Occurrence of at least one of A or B is nothing but the event A or B. So it is asking us to show that, okay, we need to show that P of A union B, right? P of A union B equals 1 minus P of A into P of B. So it is given that A and B are independent events. By that we concluded that P of A intersection B equals P of A into P of B, and also by the question we need to show that what P of A union B equals 1 minus P of A dash into P of B dash. So what we are going to do is, we are going to start from the LHS, that is P of A union B, and then we are going to prove the RHS. Okay, we will consider the LHS. We will consider the LHS P of A union B. So by the first PUC result of probability, okay, I can write P of A union B equals P of A plus P of B minus P of A intersection B. This follows from first year probability chapter, right? We have come across this result and I have also recalled this result in the first session. Okay, P of A union B equals P of A plus P of B minus P of A intersection B. Okay, moving forward, the next step, I will write P of A plus P of B as it is, okay, minus P of A intersection B. A intersection B, I can write it as P of A into P of B. So in the place of P of A intersection B, I will write minus P of A into P of B. Okay, this follows from this result. Next step, P of A plus, look at the last two terms. We have P of B minus P of A into P of B. From these two terms, I will take P of B common. Okay, from this last two terms, P of B and minus P of A into P of B, I take P of B common. What do we get? 1 minus P of A we get. So we get P of B into 1 minus P of A. Okay, moving further, this is P of A plus P of B. What is the result involving P of A dash? How can I write P of A dash? I can write P of A dash equals 1 minus P of A. So in the place of 1 minus P of A, I will write P of A dash. This is because P of A dash equals 1 minus P of A. This again is a first PUC probability result. Okay, moving forward, I will write P of A here, okay, from the same formula. I can write P of A as, okay, P of A, I can write it as 1 minus P of A dash. So these two are one and the same results. P of A dash is 1 minus P of A, okay. From the same result, P of A, we get it as 1 minus P of A dash. So for this P of A, I substitute 1 minus P of A dash. So I have 1 minus P of A dash plus P of B into P of A dash, okay, as it is. Now, look at this. I'll rewrite this. 1 minus P of A dash plus P of B into P of A dash we have. From the last two terms again. Which are the last two terms? Minus P of A dash and plus P of B into P of A dash we have. I will take minus P of A dash common from these two terms, okay. What am I left with? 1. I am taking minus P of A dash common from these two terms. So I write minus P of A dash. If I take common, what am I left here? I am left with 1, right? Because I am taking minus P of A dash common, I am left with 1. Again, from this term, I am taking minus P of A dash common again. So if I take minus P of A dash common, what am I left with? Minus P of B. Okay. What have we done for this step? We had 3 terms in the previous step. 1 minus P of A dash and plus P of B into P of A dash. What have I done? I have taken minus P of A dash common from the last two terms. So what am I left with? 1 minus P of A dash into 1 minus P of B. Okay, moving further, 1 minus P of A dash common. What is 1 minus P of B? How can I write that as? Using this formula, same formula, P of A dash equals 1 minus P of A. Hence, I can also change this formula to P of B dash equals 1 minus P of B. So 1 minus P of B, it is nothing but P of B dash. This follows from, since P of B dash is 1 minus P of B. So we have arrived at the result 1 minus P of A dash into P of B dash. This is what we wanted. How did we start it? We started from the LHS P of A union B, and we used certain probability formulae that we knew, and we arrived at the result 1 minus P of A dash into P of B dash. Okay, moving on, write down the next problem. If P of A equals 3 by 5, this is the next problem. If P of A equals 3 by 5 and P of B equals 1 by 5, then find P of A intersection B. Then find P of A intersection B if A and B are independent events. If A and B are independent events. I repeat the question once again. If P of A equals 3 by 5 and P of B equals 1 by 5, find P of A intersection B if A and B are independent events. Okay. Now look here. What is given in the question? It is given that P of A value is 3 by 5, P of B value is 1 by 5. We need to find value of P of A intersection B. What else is given? It is also given that A and B are independent events. Now, if A and B are independent events, how can we start the solution as A and B are independent events? By definition, what can I write? So, by the given data, I can write P of A intersection B is equal to P of A into P of B. So by the given data, I can write P of A intersection B equals P of A into P of B. That is because A and B are independent events. Okay, what should we find? We have to find out the value of P of A intersection B. Do we know the value of P of A? Yes. P of B value? Yes. We just substitute here, find out value of P of A intersection B. So what do we have? P of A is 3 by 5. P of B is 1 by 5. So this is nothing but 3 into 1 is 3. 5 into 5 is 25. So the value of P of A intersection B, we get it as 3 by 25. So we have used what is given, we have used the definition of independent events, and we have found out the value of P of A intersection B. Okay, moving on, write down the next problem. A fair coin and an unbiased die, a fair coin and an unbiased die are tossed. Full stop. Next sentence. Let capital A be the event. Let capital A be the event. Head appears on the coin. Head appears on the coin. and capital B and capital B be the event 3 on the die. Capital B be the event 3 on the die. Full stop. Next sentence, check whether A and B are independent events or not. Check whether A and B are independent events or not. I repeat the question once again. A fair coin and an unbiased die are tossed. Let A be the event, head appears on the coin, and capital B be the event, 3 on the die. Full stop. Next sentence, check whether A and B are independent events or not. Check whether A and B are independent events or not. Okay, look at the question. What is the question asking us to do? What is the random experiment in the question? A fair coin and an unbiased die are tossed. So if a fair coin which is having 2 outcomes, heads or tails, and an unbiased die which is having 6 outcomes, 1, 2, 3, 4, 5, 6. If these 2 are tossed, what is the sample space of this random experiment? Correct. You will have H1, heads on the coin, 1 on the die. H2, heads on the coin, 2 on the die. H3 up to H6. So, heads on the coin, 1, 2, 3, 4, 5, 6, 6 different outcomes. Then, tails on the coin, 1 on the die, right? Tails on the coin, 2 on the die. So on, tails on the coin, 6 on the die. So, totally, we'll be having 12 possible outcomes for this random experiment. So the sample space will start like this. The sample space is capital S equals, okay, H1. H1 means heads on the coin, 1 on the die. H2, heads on the coin, 2 on the die. H3, H4, H5, H6. Then tails on the coin, 1 on the die. That is T1, T2, T3, T4, T5 and T6. So this is the sample space of the random experiment. A fair coin and an unbiased die are tossed. So totally we have 12 possible outcomes for this random experiment. Now, what is the 2 given events here? Event A is given to be head appears on the coin, right? And event B is given to be 3 on the die. Now, what is set A equal to? If A is head appears on the coin, what might set A be equal to? Head on the coin is H1, H2, H3, H4, H5 and H6. So set A is H1, H2, H3, H4, H5 and H6. Look at event B, 3 on the die. 3 on the die is nothing but H3, there is a 3 on the die. T3, that is another 3 on the die. So we have H3 and T3. How many elements in set A? Set A has 6 elements. So N of A equals 6. How many elements in set B? Set B has 2 elements. N of B is 2. Okay, now that we have written all these things, we have to see if A and B are independent events or not. So what do? to prove that A and B are independent events, we have to prove that P of A intersection B equals P of A into P of B. If those are not equal, then we will conclude that A and B are not independent. Okay, we'll see that now. P of A intersection B. P of A intersection B. By definition of probability, what can we write this as? It is N of A intersection B divided by N of S, right? So we need the number of elements in the set A intersection B. So we will first find out the set A intersection B. What is the set A intersection B? It is nothing but the common elements between the sets A and B. Which is the common elements, or which are the common elements between these two sets? Only one element is there, that is H3. So obviously you can see that there is only one element common to A and B. Hence A intersection B is singleton H3. How many elements? One element. So I'll write N of A intersection B equals 1. So to find out P of A intersection B, what is N of A intersection B? It is 1 divided by N of S. N of S is 12. So value of P of A intersection B is 1 by 12. What else do we need? We need the values of P of A and P of B. By definition of probability again, P of A can be written as what? N of A by N of S. What is N of A? N of A is 6, N of S is 12. So 6 by 12, on further simplification, we get 1 by 2. Similarly, P of B. P of B is N of B by N of S. N of B is nothing but 2. N of S is 12. So that is 2 by 12. On further simplification, we get 1 by 6. Now we have to check whether P of A intersection B equals P of A into P of B or not. Okay, we'll start with this, or we'll start with the RHS. P of A into P of B. P of A, we'll consider this. Consider P of A into P of B. P of A is 1 by 2. 1 by 2 into P of B is 1 by 6. 1 by 2 into 1 by 6 is 1 by 12. But what is 1 by 12? 1 by 12 is nothing but P of A intersection B. So what have we proved? We have proved that P of A into P of B equals P of A intersection B. So if this is so, if this is true, P of A intersection B equals P of A into P of B, what can we conclude about the events A and B? Events A and B are independent events. Moving on to the next problem, write down the next problem. A die marked 1, 2, 3. A die marked 1, 2, 3 in red and 4, 5, 6 in green. A die marked 1, 2, 3 in red, 4, 5, 6 in green is tossed. Is tossed. Full stop. Next sentence. Let A be the event. Let capital A be the event. The number is even. The number is even. The number is even. And capital B and capital B be the event. The number is red. the number is red. Full stop. Next sentence, are A and B independent? I repeat the question once again. A die marked 1, 2, 3 in red and 4, 5, 6 in green is tossed. Full stop. Next sentence, let capital A be the event, the number is even, and capital B be the event, the number is red. Full stop. Next sentence, are A and B independent? Okay. Now same thing, if we have to prove that A and B are independent, we have to prove that P of A intersection B equals P of A into P of B. So we will check whether P of A intersection B is equal to P of A into P of B or not. We'll start with the solution like this. What is the random experiment? We have a die wherein 1, 2, 3 is marked as red and 4, 5, 6 is marked in green. Okay, if this die is tossed, okay, what is the sample space? Sample space is nothing but 1, 2, 3, 4, 5, 6. So the sample space is capital S equals 1, 2, 3, 4, 5, 6. How many elements in the sample space? We have 6 elements in the sample space. Look at event A. Event A is number is even. So what is set A equal to? What are the even numbers? 2, 4 and 6. How many elements in event A? We have 3 elements in event A. Look at event B. Event B is saying number is red. So what is set B equals to? Which are the numbers in red? 1, 2, 3. How many elements in set B? Again we have 3 elements in set B. Okay, now we have to find out whether P of A intersection B equals P of A into P of B or not. We have to find out P of A intersection B. How do we do that? N of A intersection B by N of S. What is N of A intersection B? To find this out, we have to first of all find out the set A intersection B. Common elements between the sets A and B. Which are the common elements between sets A and B? 2 is the only common element between sets A and B. Hence, A intersection B will be nothing but singleton 2. How many elements in A intersection B? We have 1 element. Okay, so N of A intersection B is 1 divided by N of S is 6. So probability of the event A intersection B, we are getting it as 1 by 6. What is probability of A? P of A is N of A by N of S. N of A is nothing but 3. N of S is nothing but 6. 3 by 6 on simplification gives us 1 by 2. So probability of event A is 1 by 2. Again, P of B, it is nothing but N of B by N of S. N of B is nothing but 3 again. N of S is 6. This is again equal to 1 by 2. Now we have to see whether P of A into P of B equals P of A intersection B or not. We will start from P of A into P of B. So I write, consider P of A into P of B. What is P of A? P of A is 1 by 2. P of B is 1 by 2. 1 by 2 into 1 by 2 gives us 1 by 4. But what is P of A intersection B? It is nothing but equal to 1 by 6. So I can write this is not equal to 1 by 6, which is P of A intersection B. So we can clearly see that P of A into P of B is not equal to P of A intersection B. So what can we conclude about the events A and B? They are not independent events. Okay, moving forward, write down this question. Let capital E and capital F, let capital E and capital F be the events, let capital E and capital F be the events with P of E equals 3 by 5, P of F equals 3 by 10, and P of E intersection F equals 1 by 5. Full stop. Let E and F be the events with P of E equals 3 by 5, P of F equals 3 by 10, and P of E intersection F equals 1 by 5. Full stop. Next sentence. Are E and F independent? Are E and F independent? Okay. Same thing, we are going to use the definition of independent events. P of A intersection B equals P of A into P of B or not. Okay. In this case, it is given the events are E and F. So we have to check whether P of E intersection F equals P of E into P of F or not. Okay, we'll do that. We'll start from P of E into P of F. So we'll consider P of E into P of F. So what is P of E? P of E is 3 by 5. What is P of F? P of F is 3 by 10. So on simplifying this, what do we get? We get 3 3s are 9, 5 10s are 50. So we get 9 by 50. But what is P of E intersection F? P of E intersection F is given to be 1 by 5. So what can you say about P of E into P of F? It is not equal to P of E intersection F. P of E intersection F, which is 1 by 5, is not equal to 9 by 50, is not equal to 9 by 50. What is 9 by 50? Nothing but P of E into P of F. So what can we conclude about the events E and F? They are not independent events. They are not independent events. Okay. Moving forward, write down the next question. Given that the events A and B, given that the events A and B are such that P of A equals 1 by 2, P of A union B equals 3 by 5, and P of B equals small letter p. I repeat once again, given that the events A and B are such that P of A equals 1 by 2, P of A union B equals 3 by 5, and P of B equals small letter p. Next sentence, find P if they are sub-question 1, mutually exclusive. Mutually exclusive. Sub-question 2, independent. Sub-question 2, independent. Independent. Okay. I repeat the question once again. Given that the events A and B are such that P of A equals 1 by 2, P of A union B equals 3 by 5, and P of B equals small p, full stop. Next sentence, find small p if they are sub-question 1, mutually exclusive, sub-question 2, independent events. Okay. Look here. What is given? P of A value is given, P of A union B value is given, and P of B is given to be small p. We have to find out value of P if A and B are first of all mutually exclusive events. What is the meaning of mutually exclusive events? If I say A and B are two mutually exclusive events, what do we mean by that? We mean that A intersection B is an empty set. Or in other words, what will be the probability of intersection of these two sets? It will be nothing but 0. So if A and B are mutually exclusive events, then we can safely say P of A intersection B will be equal to 0. Okay. Now we have to find out value of small letter p, right? What is given to us? Value of P of A union B is given, value of P of A is given. Now if A and B are mutually exclusive events, what happens to this result? What is P of A union B equal to? I can write it as P of A plus P of B, right? How do we get this result? We know the result. P of A union B equals P of A plus P of B minus P of A intersection B. But what is P of A intersection B? It is nothing but 0. So this becomes 0. Hence, what is P of A union B equal to? It is P of A plus P of B. We will substitute the values and try to find out value of P of B or P. Okay, what is P of A union B? It is 3 by 5 equals, what is P of A value? It is 1 by 2 plus P of B value is given to be small letter p. Okay, from this we can easily find out value of P. Taking 1 by 2 on the LHS, what happens? We get P equals 3 by 5 minus 1 by 2. On taking LCM here on the RHS, what is the LCM? LCM is 10. So 10 is the LCM. What are we left with? 6 minus 5, which is 1 by 10. So if A and B are mutually exclusive, what is the value of P? Value of P is 1 by 10. Similarly, we have to find out value of P if A and B are independent events. We'll do that now. A and B are independent events. So if A and B are independent events, by definition of independent events, what can I write? P of A intersection B equals P of A into P of B. This follows from definition of independent events. Okay. Now, P of A intersection B is not given to us. Okay. What happens to this? P of A intersection B equals P of A. P of A value is 1 by 2 into P of B value is given to be small letter p. So P of A intersection B is nothing but 1 by 2 into P. Further I can write this as P by 2. Okay. We will again use the result P of A union B equals P of A plus P of B minus P of A intersection B. So we know that P of A union B is nothing but P of A plus P of B minus P of A intersection B. Okay. What is P of A union B value? It is 3 by 5. P of A union B is 3 by 5 equals P of A is 1 by 2 plus P of B value is small p minus what is P of A intersection B value? It is P by 2. Okay. So we have substituted the values of P of A union B, P of A, P of B and P of A intersection B. We'll simplify this further. I can write this as 3 by 5 equals 1 by 2 as it is. P minus P by 2 is giving us P by 2. Okay. I'll take half on the LHS. What happens? We have 3 by 5 minus half equals P by 2. So this is 3 by 5 minus half equals P by 2. On taking LCM on the LHS, LCM is 10 here. Okay, what are we left with? 6 minus 1 equals, 6 minus 5, okay, equals, this is P by 2 as it is. What is 6 minus 5? It is 1 by 10 equals P by 2. Further simplifying this, 2 ones are 2 5s are 10. So what is the value of P? The value of P we are getting is 1 by 5. So if A and B are independent events, then value of P is 1 by 5. Similarly, if A and B are mutually exclusive events, value of P is 1 by 10. Okay, moving forward, write on this question. If A and B are two events, if A and B are two events such that P of A equals 1 by 4, P of A equals 1 by 4, P of B equals 1 by 2, P of B equals 1 by 2, and P of A intersection B and P of A intersection B equals 1 by 8, find P of not A, P of not A and not B. Find P of not A and not B. I repeat the question once again. If A and B are two events such that P of A equals 1 by 4, P of B equals 1 by 2 and P of A intersection B equals 1 by 8, then find P of not A and not B. Okay, look here. First we have to see what is P of not A and not B. We'll start the solution like this. We'll consider P of not A and not B. Okay. So how can I write not A as? What is the event not A? It is the complementary event of event A. It is denoted as A dash, right? So not A is A dash. And so what is the symbol for and? and can be translated to the intersection operation, right? So not A is A dash and can be translated to the intersection operation of sets. Again, not B is nothing but B dash. So P of not A and not B is nothing but P of A dash intersection B dash. Okay, now moving forward, by using De Morgan's laws of sets, okay, I will write A dash intersection B dash as A union B whole dash. By using De Morgan's laws, I have written A dash intersection B dash as A union B whole dash. This follows from De Morgan's law. What is De Morgan's law? A dash intersection B dash is nothing but A union B whole dash. So A dash intersection B dash, I have written it as A union B whole dash. Further, we will use the formula P of A dash. How can I write P of A dash as 1 minus P of A? In the place of A dash, I have A union B whole dash. So what happens to P of A union B whole dash? I can write this as 1 minus P of A union B. So this follows from the result, since P of E can be written as 1 minus P of E dash. Okay, or we'll further simplify this for this. Okay, I can in fact write it as P of E dash equals 1 minus P of E. So both that previous formula also is same as this. Okay, P of E dash equals 1 minus P of E. In the place of E, we have A union B. So P of A union B whole dash becomes 1 minus P of A union B. Moving forward, what is P of A union B? How can I write P of A union B in terms of P of A, P of B and P of A intersection B? Okay, 1 minus, I have P of A union B. P of A union B is nothing but P of A plus P of B minus P of A intersection B. This result we have used many times now. P of A union B equals P of A plus P of B minus P of A intersection B. All those three values are given to us in the problem. Substituting those values, we get what? 1 minus P of A value is 1 by 4 plus P of B value is 1 by 2 minus P of A intersection B value is 1 by 8. On further simplifying inside the brackets, what do we get? 1 minus. What is the LCM here? I can take the LCM as 8 here. So what am I left with? 2 plus 4 minus 1 in the numerator. So what is this equal to? 1 minus of 2 plus 4 is 6. 6 minus 1 is 5 by 8. On further simplifying this, taking the LCM as 8 here, 8 minus 5 we get. 8 minus 5 is nothing but 3 by 8. Okay, so we have found out the value of P of not A and not B. What is value of P of not A and not B? It is 3 by 8. All we have done is we have used many formulae from first PUC probability as well as certain second PUC results in probability, and we have found out the value of the required term. So we will continue in the next class. That's it for today. Thank you.